Now we're going to talk about parameterizing a curve. So this comes from the textbook. When an object moves along a curve or a curvilinear path in a given direction and in a given amount of time, the position of the object in the plane is given by the x-coordinate and the y-coordinate. However, both x and y vary over time, so are functions of time. So in the making it in parametric equations, we come up with a new parameter. So we're going to talk about that. In this case, time is one example. So for this reason, we add another variable, the parameter, upon which both x and y are dependent functions. Often the parameter is time, t, and we get the functions x of t and y of t. Together, x of t and y of t are called parametric equations and generate an ordered pair, x of t comma y of t. Parametric equations primarily describe the motion and direction. So parametric equations suppose t is a number on an interval I, a set of ordered pairs x of t, y of t, where x equals f of t and y equals g of t forms a plane curve based on the parameter t. The equations x equals f of t and y equals g of t are the parametric equations. And I alluded to this in our introduction, that another thing about parametric equations, like as we look at what is a function, what is not a function in the vertical line test and so on, that under parametric equations we could have something that appears to be a circle, but x is a function of t and y is a function of t, so they don't violate the vertical line tests as respective functions. So parameterize the curve y equals x squared minus 1, letting x of t equals t. I'm going to graph both sides. So I am going to admit that this is a little bit, the lazy way. It would just saying x of t equals t. We could make it more interesting as we go on with this. Like what if we said that x of t is the square root of t, so that t is x squared. That makes something different. But if we go with x of t equals t, then our y of t would just be, I'm putting the t in place of x up here, is going to be t squared minus 1. Okay, so if we were to graph this, and I've got to think about where should we start graphing this, we'd come up with multiple columns, and I don't know why it's not going to blue like it's supposed to. Okay. We would have t, x of t is just going to be the same as t. Then y of t, which is t squared minus 1. So let's go with, like, I don't know, maybe start at negative. If we go negative 3, it's going to be too big. So negative 2, we get negative 2 for this one, and negative 2 squared minus 1 is going to be 3. We'll go negative 1, negative 1. Negative 1 squared minus 1 is 0. 0, 0. 0 squared minus 1 is negative 1. 1, 1. 1 squared minus 1 is 0. 2, 2. 2 squared minus 1 is 3. If I went 3, 3 squared minus 1 is, that's going to be 9 minus 1 is 8. My graph only goes to 5. So if I were to graph this, negative 2, 3. Negative 1, 0. 0, negative 1, 1, 0, and 2, 3. And what we're seeing is this parabola that is going in this direction. So as I said, as the book said, so I'm going to include it this way, arrows indicating the direction as time gets bigger that this is going in. And that is the idea behind a parametric equation. So it's not just the graph, but as t gets bigger, which way is this graph going? Okay, let's move on to another example. Find a pair of parametric equations that models the graph of y equals 1 minus x squared using the parameter x of t is t. So again, I'm not thrilled with that option. I like something a little more creative, but we will have the chance towards the end of this section to do that. 1 minus t squared. Okay, so if I were to look at a chart for this, thinking about this, I think I'm still kind of limited to the same values, t x of t, which is t, and y of t is 1 minus t squared. So we'll go with -2, -1, 0, 1, and 2. So it's -2, -1, 0, 1, and 2. Now I'll do 1 minus -2 squared. So 1 minus 4 is 3, negative. 1 minus -1 squared is going to be 0. 1 minus 0 squared is 1. 1 minus 1 is 0. And 1 minus 3 is negative. 1 minus 4 is -3. Okay, so we're going to be looking at this graphically. -2, -3. -1, 0. 0, 1. 1, 0. And 2, -3. So again, we have a direction for this that goes the following like that. So this is going in that direction. Okay. And we have another one from this video set we're going to do. And it says an object travels at a steady rate along the straight path, -5, 3, to 3, -1 in the same plane in 4 seconds. The coordinates are measured in meters. Find parametric equations for the position of the object. So let's look at this in two parts. Since we're doing parametric equations, so on the x part, it's going from -5 to 3. So 3 minus -5 is 8. And 8 divided by 4 seconds is 2. So we can see how this progresses, and we can come up with the equation x of t is 2 from here times t as our increment minus 5, meaning when time is 0, it's at -5. Same thing with the y. So y is going from 3 to -1. So -1 minus 3 is -4. -4 divided by the 4 seconds is -1. So that'd be like our slope, so to speak. So y of t is going to be equal to -1, but it starts at 3. So when -1 times t plus 3, because that's where it starts. So -t plus 3. So now we can go ahead and try plotting this from 0 to 4. So we'll have a time column, an x column, and a y column. I give myself a lot of space. So I might need to come over to draw this over here instead. Maybe instead I'll do this. T, do horizontal lines. How's that? T, x, and y. This will be different. Okay, so we'll do 0 time, 1, 2, 3, and 4 using these equations. So -5, and then this starts at 3. And then I put a 1 in there. So I'm looking at this equation and this equation. 2 times 1 is 2, minus 5 is -3. So -1 plus 3 is 2. Put a 2 in there for t. We're going to get 2 times 2 is 4, minus 5 is -1. -2 plus 3 is +1. 2 times 3 is 6, minus 5 is 1. And then -3 plus 3 is 0. Then I'm going to put 4 in there. 2 times 4 is 8. Minus 5 is 3. And then -4 plus 3 is -1. So it looks like we're getting to the right places. So we can plot this. We have -5 corresponds to 3. And then we have -3 corresponds to 2. And then we have -1 corresponds to 1. Then we have 1 for x corresponds to 0 for y. Then we have 3 for x corresponds to -1 for y. So we have a graph that looks like this, and it's going in that direction. Okay.